amazing session with the Elite Tutor. Your learning is made very, very simple. And in today's video, we are going to look at the laws of indices, part 2. We looked at part 1. Here we looked at the definition of indices. We looked at about 4 laws of indices. We looked at the division law, which is known as the quotient law. We looked at the product law, which is known as the multiplication law. We also looked at the power of power law, and we also looked at the power of product law. So I would recommend every one of you currently watching this part 2 to go visit the part 1. But in today's video, we are going to be looking at 3 laws of indices, and I want you to follow closely. Now, the first law of indices we are going to be looking at, we are going to look at the zero index law. We are going to look at what? The zero index law. So firstly, what do we mean by this zero index law? This zero index law means anything raised to the power of 0 is 1. That's what the zero index law states. Anything raised to the power of 0 is 1, not 0. So it means that 100 raised to the power of 0 gives us 1. That's the zero index law. So we have the first one. We have zero index. So we say if A raised to the power of 0, it gives us 1. So our zero index law is being expressed at what? A raised to the power of 0 is 1. Meaning anything raised to the power of 0 is 1. Now let's look at that example 1 where we have 5 raised to the power of 0. We have that 5 raised to the power of 0 using our zero index law. It means that 5 raised to the power of 0 gives us 1. Now, students, there are times when students make mistake. Now, when students see questions like, we have 5 raised to the power of 1. 5 raised to the power of 1, they write what most times they usually write what? 1. And this is wrong. For you to apply the zero index law, the power has to be 0. 5 raised to the power of 1 means that 5 is going to multiply itself just once. So the next law of indices we are going to look at for this video, we are going to be looking at the negative index law. Very important. We look at the negative index law. We have two. We have the negative. We have the negative index law. So what does this mean? The negative index law firstly is being expressed as we have A raised to power negative 1. Now, first of all, why do we have this negative index law? This negative index law acknowledges the fact that whenever we have a number with a negative power, in order for us to remove that negative power, we divide by 1. We simply take the reciprocal. We simply will divide by 1. So this A raised to power negative 1 is equal to 1 divided by A raised to power 1. So because we are dividing by 1, the power becomes positive. Now let's look at our example 2. When we have 2 raised to power negative 3, we are going to apply the negative index law because the power here is negative. So in order for us to remove the negative power, we are going to use 1 to divide. So this we are going to arrive at 1 divided by 2 raised to power 3. Because we are dividing by 1, because our 1 is a numerator, we are dividing by 1, that's that the power is no longer negative but positive. So we don't stop here. So this is 1 over. Now, what is 2 raised to power 3? 2 raised to power 3, it's not 2 times 3. It's simply 2 multiplying itself 3 times. And that's the definition of indices. Indices tells us the number of times a number is multiplied by itself. So when we have 2 raised to the power 3, it simply means we have what? 2 times 2 times 2. 2 multiplied itself 3 times. So 2 times 2 we have 4. 4 times 2 we have 8. So our final answer is 1 over. The answer gives us 1 over 8. Now before moving to the next law, which is the fractional index law, I want us to look at question 5. Why are we looking at question 5? Because question 5 relates very well with the negative index law. And when we see a question like that, how do we solve such question? So I want you to pay close attention. So we have, for example, we have 1 whole number 4 raised to the power negative 1. How do we attempt such questions? Now you're going to take this question step by step, and I want you to follow closely. Now the first thing we are going to do, we are going to look at trashing, you're going to look at solving the denominator first. Now this is a fraction. We have our numerator, which is 1, and our denominator, which is 4 raised to the power negative 1. So we're going to look at solving for our denominator first. So if we bring out our denominator, we'll have that 4 raised to the power negative 1. And if we apply our negative index law, we don't want a negative power, we want a positive power. So this gives us 1 over 4 raised to the power 1. This power is no longer negative, it's now positive. And this, our final answer is same as what? 1 over 4. Because 4 raised to the power 1 is 4. What does it mean? It means that 4 is multiplying itself. You see that 4 is just multiplying itself just once. Now, we have our final answer is 4. Don't forget, 1 over 4 here, it's our denominator. We still have our numerator here, which is T1. So this, bringing out our numerator, we have that this is 1 divided by 1 over 4. 1 from our numerator divided by our denominator, which is now what? 1 over 4. Now we can go ahead to rewrite this expression to be 1 over 1 divided by 1 over 4. 1 and 1 divided by 1 is the same thing. What has only happened here is that 1 has changed form. And if you can remember very well, whenever we want to divide fraction, what do? We can convert or change our division sign to multiplication. But once we do that, the denominator becomes the numerator, while the numerator becomes the denominator. So they get to swap position. What do we mean? So we have that 1 divided by 1 times 4 over 1. The denominator now is not the numerator, while the numerator is not the denominator. Then we can go ahead to multiply 2. So we have that 1 times 4 divided by 1 times 1. So our final answer gives us 1 times 4 is what? 4. And 1 times 1 is 1. And 4 divided by 1 gives us 4. And this is our final answer. So when we have 1 divided by 4 raised to the power negative 4, our final answer is 4. And finally for this video, the last question we're going to be solving, the last law you are going to be looking at, the fractional index law. Please pay attention. The fractional index law. Now, we have our third law, which is the fractional index law. Now, the fractional index law is being expressed as 1 raised to the power 1 over 2. Now, why is it called fractional index? This is secret because the power is in fraction. That's why it's called the fractional index law. Because a number or a variable is being raised to a fraction. That's when I want you to pay attention. Now, in a fraction has two sides. If this is a fraction 1 over 2, it has two sides. The up part, which is the numerator, and the down part, which is the denominator. Please, I want you to pay attention. Now, the denominator always takes the root. What? Sorry? The denominator always takes the root. Why? The numerator takes the power. When we talk about the fractional index law, a number or a variable is usually raised to a fraction. A fraction has two parts, the numerator and the denominator. The denominator is always the root, while the numerator is always the power. Now, what do we mean? Please pay attention. Now, in this scenario, you are going to have that the root, which is the denominator, we have that what? Square root of a. While the numerator always takes the power, which is what? Raised to power a raised to power 1. So a fractional index law is being expressed in this format. Now in this question, I'm going to be solving question 3 and 4 in order for us to understand this fractional index law properly. Now let's look at question 3. Question 3 we have 16 raised to power 1 over 2. Now how do we solve this? Like I said, the denominator always takes the root, while the numerator is the power. So we're going to have that this is square root of 16. Why is it square root? Because my denominator is 2. And the power here will be 1. Why? Because my numerator is 1. Please take note. The denominator always takes the root form, while the numerator takes the power. And the first thing we are going to do, we are going to first of all solve what? The root before application of the power. You solve the root first before the application of the power. So we are going to have that square root of 16. The square root of 16. The square root of 16 gives us what? 4 raised to power of 1. Now most people will be asking, when we have this sign, this is already square root. Why are we still adding 2? Yes, we know. We are adding the 2 for understanding. Because there are times when here might not be, the denominator might not be 2, probably might be 3, might be 4. So when it's 3, we might be looking for the cube root. When it's 4, we might be looking for the fourth root. So we have that square root of 16 gives us 4, and the power is 1. So we have that 4 raised to power 1 gives us 4. And our final answer is 4. And finally, for this video, we are going to be looking at question. We are going to be looking at question 4. Question 4, we have 9 raised to power 3 over 2. Now, it's very important for you to know that the numerator is always a power. Because in a situation where the numerator is not 1, and rather the numerator is 3, what do we do? Now, first of all, this is expressed as square root of 9. Why is it square root? Because the denominator is 2. And the square root of 9 raised to the power of 3. Why is it 3? Because my numerator is 3. And like I said, the denominator is always the root, while the numerator is always the power. So we're going to have that square root of 9. Square root of 9 gives us 3. So how that this is what? 3. Not just 3. Don't forget your numerator, which is the power. 3 raised to power 3. And what is 3 raised to power 3? Based on our definition of indices. When we talk about indices, we are talking about the number of times a number is multiplied by itself. So when we say 3 raised to power 3, we are simply saying 3 multiplied itself 3 times. So that is 3 times 3 times 3. So when we have 3 times 3 times 3, our final answer gives us 20. Our final answer gives us 27. So we've come to the end of this very video. Ensure you like, share, and subscribe. Thank you.